Hi, um, in this video I'm going to show you how a light sensor circuit works. Um, this symbol here is a symbol of a bipolar junction transistor, otherwise known as a BJT. The B represents the base, this is the emitter and the collector. Base, emitter and collector. The voltage here is what we call the base voltage. When the base voltage is greater or equal to 0.7 volts, the transistor here will be turned on. When the transistor is turned on, it will allow current to flow through the collector to the emitter and hence lighting up the LED over here. In the previous videos, we already know why there is a 470 ohm resistor here. The 470 ohm resistor is really to protect the LED from blowing. So these two components go hand in hand. Over this side of the circuit is what we call a potential divider circuit. It is called a potential divider because it divides the potential across here, okay, which in this case is 9 volts. So it's 9 volts over here and 0 volt potential over here. This component here is what we call a light dependent resistor, otherwise known as an LDR. When it is dark, the LDR has a very high resistance of about 2 mega ohm, and when there is light, the chemical coating on it will be agitated and reduce the resistance to between 0.4 to 20 kilo ohm. So in other words, when it is bright, resistance is low. When it is dark, resistance is high. So assuming that it is dark and resistance is very high, you find that the voltage here will be 9 volts and here will be 0 volts. If the voltage here reduces, some of the voltage will come over here, so this could be 7 volts and here could be 2 volts. And if it reduces further, more voltage will come over here. So basically the sum of these two voltage across these two components will equal to 9 volts. So therefore, in a dark condition, we find that the voltage across the 22K resistor is 0 volts. So therefore, when VB is 0 volts, the transistor is off. And when the transistor is off, current cannot pass through, the LED is also off. So again, when it is dark, transistor is off because voltage here is 0, transistor is off, LED is off. When it is bright, the voltage VB increases, turning on the transistor, allowing the current to flow through, and hence the LED is on. So when it is bright, transistor is on and LED is on. When it is dark, resistance is high, the transistor is off and LED is off. Now let me show you an example of how the circuit will look like when we connect it all up. Over here you see the circuit. Okay, we have attached the LDR over here, the 22K resistor, 470 resistor, the LED, the batteries are connected. Now you see all these silverish solder. The reason why I solder it on is so that it stays on it longer. There is no polarity for the LDR, the resistor, but there is a polarity for the LED. So take note that the longer leg goes on the triangle side, the shorter leg goes on to the where the straight line is. For the BJT, it is actually a semicircle. One side is curved and the other side is flat. The flat side, place it flush with the paper like this. The center leg would be the base and the upper leg would be the collector, and here will be the emitter. So this is how you connect the circuit. Now, So in this case, this is a dark condition, there is no light. Dark condition, there is no light, LED is off. So when we allow a light source to come in, when a light source comes in, it becomes bright, resistance reduces, voltage here increases, turning on the transistor, allowing current to flow through, lighting up the LED. And when the light source is removed, when it is dark, you find that when it's dark, resistance will go back up, voltage VB will be 0, transistor off, current cannot flow through, therefore the LED is off. So this is a thank you for watching the video, and I hope you have learned something about how a light dependent resistor can be used as a light sensor.